Welcome to Derivative Rules. We are looking at the shortcuts, the rules to finding derivatives. We just finished up using the definition where the limit as h approach 0 of f of x plus h minus f of x all over h was the derivative. But maybe as you guys were working through some of those problems, you realize there seem to be some shortcuts to some of these, and that's what we're going to talk about today. So the majority of what we're going to be using is these rules to kind of speed up the process a little bit, but we don't want to forget about what a derivative is, which has to do with the slope of the tangent line and going back to that kind of proof that I showed you as to what what this represents. So here are the rules. We have the function, and then I'm going to give you the derivative. So the first one is f of x equals c, and so this is something like f of x equals 2. Alright, so when we did our constant, you guys noticed pretty quickly that the derivative was always going to be 0. Okay, so that's true for all constants. What if we had x raised to a power? So f of x equals x squared. Alright, well what happens is the exponent, alright, which is the n, moves to the front. So the exponent moves to the front. So for example, on this one, the 2 would move to the front, and then the base x stays there, but then you subtract 1 from the original. Well, the original was 2, so 2 minus 1 is 1. So it'd be 2x to the first. And I'm going to do examples of these, but just to kind of get you guys to see as to where these things are coming from. On the next one, we have a coefficient in front of the x to the n, so that really just stays there, and then it repeats the one above it. So the n moves to the front, now gets multiplied by that coefficient of c, and then you still subtract 1 from the exponent. With addition, the nice thing about this is when you have two functions being added, such as polynomials, you guys did some linear ones as well, like 3x plus 2, then you just need to take the derivative of each individual term and then keep those added together. So those are the first three. The first four. Here are the next three, a little bit more complex. The first one is, you see the product g of x times h of x, and so as you write this down, pay attention. You're taking the derivative of one and not the other, and then adding those two together. So the first part is you're taking the derivative of the first function, then you're just multiplying it by h of x, then you'll add, and then now it switches. Now you'll take the derivative of the second function and multiply by just the g of x. So we will need to know these rules because these are our, help us speed up the process here. The next one is division. So if you look on division, it's a little different than the book, but we set it up. I kind of set it up to help you kind of memorize these a little bit easier as you use these, is that this right here for the product is exactly the same for the quotient. So you'll do the same thing. You'll take the derivative of g of x times h of x, but you'll subtract instead of add. And then you'll also divide by not the derivative, but just h of x squared. So you'll take whatever this function is and you'll just square it. And then the last one is when you take a function and raise it to a power. So there's a couple of things going on here. It's very similar to the second one that we looked at. So the n will move to the front, so there's that. Then you subtract 1, just like earlier, from the entire function. But here's the thing that's a little different. Then you take the derivative of g of x. And this is when you have more than just one term. So this isn't just like 3 raised to the n power. This is more like 3x plus 1 raised to the 5th power, something like that. So kind of clear that out there so you can see it, but that will represent a polynomial being raised to a higher power. So those are the 7. Now I'm going to talk about these 7 as I go through, and I'm just going to, it's not like this is rule 1, 2, 3, and 4, but that's the way I'm going to kind of talk about them so you know what you're looking at as we go through and do each of these. So those are our 7 rules. Alright, let's get started. So we're going to do many problems here because these are going to go a little bit quicker than by definition, or a lot quicker than by definition. Alright, first one, f of x equals 8. Alright, which rule are we going to use? We're going to use rule number 1. Rule number 1 is your constant. Change colors. So we'll use rule number 1. That means that the derivative is equal to 0. So going back, rule number 1 represents that constant. The derivative is equal to 0. B, you got 6x squared. Which rule is that? Well, 6x squared, that's going to be rule number 3, because you have a coefficient and then x raised to a power. So what do? We say, and I'm going to write this out the first time or so you guys can see this, but the derivative, and the reason you don't see the limit anymore is because it's all incorporated in the rules. So you take 2 times, or that number goes out front, so it'd be 2 times 6, and then you take 1 away from the exponent. So that's what's happening in terms of rule number 3. So the derivative is equal to 12x to the first power. And there you go. So compare that to what you were doing the other day. Definitely a lot easier once you understand and know these rules. On the example 1c, we got 3x squared minus 12. Which rule or rules are we going to use on this one? We're going to use rule number 4 because you're adding or subtracting. And inside rule number 4, you have to do 3x squared. So that's going to be rule number 3. And then you're also going to use 1 because you do have that constant of 12 at the end. So on this one, we're using 1, 3, and 4. So you can use multiple rules as you're doing this. So the derivative, and once again I'll write it out for now, it'll be 2 times 3 x raised to the 2 minus 1, and then the derivative of 12 or negative 12 is 0. So we have the final answer, the derivative of the function f of x is equal to 6x to the first power plus 0, or just 6x. And D, why don't you go ahead and do D on your own? D is the same thing as C, just more terms. So you will be using 1, 3, and 4 again. So once again, I'm writing all this out for the first time. Once we start to learn this, we'll just go through and basically write the answer. This will be 15x to the second power minus 2 times 2 is 4, x to the first power. Now what happens right here, sometimes we get confused when it's just 7x. Well, 1 times 7 is 7, but what is x raised to the 0 power? Well, x to the 0 power is just 1, so 1 times 7 is just 7. 7x to the 0 is just 7, and then you got your plus 0 on the end here. So you can see how you go down 1 degree every time. So it was 3, now it's 2. It was 2, it's now 1. 7x was to the first, now it's to the 0, and then the constant is no longer there. In terms of its derivative, is just plus 0. So now you have 2, 1, and now the constant. So you kind of see that pattern as you go along there. Alright, let's move into some other things here. Find the derivative on this one. Now on this one, this is technically a product. It's 6 times that trinomial. But we can always simplify the function, or the original function, and then do the derivative. We don't have to do the derivative of what's written here. So if we were going to leave it this way, then we'd have to use the product, which would be number 5. But look what you have to do for number 5. Or, instead of finding the derivative right away, sorry about that. Get back to my slides here. Instead of finding the derivative right away, we can just say, okay, well, let's simplify f of x. That's 18x squared plus 12x minus 42. So that's still f of x, but now we can find the derivative of that a little bit easier. So this one I won't show my work, we'll just kind of talk through it. So this would be 2 times 18, so that's 36, and then x raised to what power? 2 minus 1 is 1. On the next one, 12x. So there's a 1 right there, so 12 times 1 is 12. 1 minus 1 is 0, so x to the 0 power is 1. And so you're just left with 12, and then you got your minus 42, so really that's, once again, plus 0, but we don't need to write that, we already got the 12 there, and that's the derivative. So we can sometimes, simplify our original function before we find the derivative. Now, I could say the same thing for number 2b here, and by the way, this was kind of using that same thing for rule 4, 3, and 1. But on b, we could go ahead and multiply. We could go ahead and use our distributive property and probably make it a little bit easier. This is the only one I have on here that's a product though, so let's go ahead and practice the product property for this one. So we're going to say f prime of x is equal to, let's go ahead and just write the derivative down in terms of its rule. So going back to number 5, it's g prime of x, h prime of x. Plus, and now we'll do h prime of x and g of x. Just want to make sure I write it in the same order that I have on here. G of x, h prime of x. And so that's what we're going to do, understanding that this represents your g of x and this is your h of x. So here we go. So this is rule number 5. So g prime of x, well, this is just a polynomial, so we'll find the derivative. So that's going to equal 3x squared, so 3 times 1, and then subtract 1 from your exponent. And then we do the derivative of the next one, which will just be minus 3. Once again, with this exponent of 1, 1 times 3 is 3. And then you get x to the 0 power, so that's g of x times h of x. Well, h of x doesn't change on this first part, so it's just x to the 7th plus 10. Plus g of x, so that's the original, times the derivative of h of x. So that'll be 7x to the 6th power, so 7 times 1, x to the 6th, and then plus 10, your constant, so that's just plus 0. When you simplify these derivatives, I want to make sure that you simplify as much as you can, as long as you don't have anything raised to the 3rd power or higher on, let's say, one of these binomials or something. So we can go ahead and multiply this out and see what we get. So 3x squared times x to the 7th would be 3x to the 9th. You add the exponents because you're multiplying. And then it looks like we have plus 30x squared minus 3x to the 7th minus 30. So this whole thing represents those two being multiplied together. Plus, now it's just a monomial times a binomial, so that's 7x to the 9th minus 21x to the 7th. And so that's that second part that's being multiplied. And now you can combine your like terms on that one. And so we'll take the highest one. That'll give us 10x to the 9th. That's the 3x to the 9th, 7x to the 9th. Then we have x to the 7th. That looks like minus 24. X to the 7th. And we have a 30x squared, so that'll be plus 30x squared, and then a minus 30 at the end there. So that one takes a little bit more work, so if you can avoid obviously the product rule in terms of derivatives, then yeah, go ahead and do so, like example 2a. And then on b, we went ahead and just kind of showed you the product property there for derivatives as well. Alright, let's go ahead and look at a couple more. Look at this one. So which rule is this one going to be? You got 5x cubed plus 4x squared minus 3. So you have a polynomial being raised to a power. That's going to be example or rule number 7 here. something being raised to a polynomial being raised to a power. So very similar to kind of what we did earlier, but now we're doing it with a polynomial. So take a look at this right here. That's the one we're going to use. So the 5 gets moved to the front, and then you multiply it by the original, which is 5x cubed plus 4x squared minus 3. And then what happens to your exponent of 5? It goes down by 1. But this isn't the end. You also need the derivative of what's being raised to the 5th power. So this will be 15x squared plus 8x, and then your constant is just 0. So this represents the derivative of g of x. This is g of x, and then we moved it as well. So look back here, so that n got moved. So whatever this was got moved to the front, multiplied by the original, subtracted 1, and then this is where we took the derivative of the last part there. And so what do we do with this? Well, there's a little bit you can simplify. You're not going to simplify this being raised to the 4th power, so I'm just going to take this 5 and multiply it by that binomial. So I'm going to distribute. Can't do that to this one because this one's being raised to the 4th power. So you'd actually have to do that first, which we're not going to do. We're not going to multiply that 4 times. That'd be too much. So 5 times 15 here. And so we get 75 x to the second. 5 and 8 is 40x. So that's one binomial. And then we'll multiply it by 5x to the third plus 4x squared minus 3 raised to the 4th power. That's as far as we're going to go with that. We're not going to go any farther. We'd have to take a trinomial raised to the 4th power, which would be a lot of work. So this is really as far as we're going to go. Alright, on 3b, we did square roots, and we had to, when we did the limit, we had to rationalize, and we had to do the rationalization technique. Well, what are we going to do here? What rule does this represent on square roots? Because if I remember my 7 rules, I didn't have anything with square roots. So how do we do this then? What is another way to write a square root? As a rational exponent, which is 1/2. So now when we go back and look, and by the way, that was rule 7. And now when we go back and look at the rules, it's really the same one we just used when you have a polynomial raised to a power. Yes, it is a rational one, but that's okay. So this will be number 7 as well. So if you want to pause and try to go through this yourself, you can, or you can kind of watch as we go along here. So the derivative, same thing we just did a second ago. 1/2 moves to the front. The x squared plus 4x minus 5 stays the same. 1/2 minus 1 is negative 1/2. So this is negative 1/2. Then we take the derivative. Well, the derivative of x squared is 2x. The derivative of 4x is just plus 4. And then the derivative of negative 5 is 0. So similar to what we had up there, and we'll do the same thing. We'll multiply this 1/2 times that binomial. We can't do it to the trinomial because it's being raised to a negative. So 1/2 times 2 is x. 1/2 times 4 is 2. And then because it's being raised to the negative 1/2, we're just going to move it to the denominator. And we could either rewrite it as a square root or leave it as a rational exponent. Either way is fine. And so there's your derivative. So we're finding out that, using the rules, yes, it's still, a lot of algebra and making sure we got things correct, but it definitely shortens up that process, especially with some of these, more lengthier ones that would be very difficult by definition to do. A couple more examples here. These are the last two. Find the derivative using the rules. Well, the one we haven't used is rule number 6, which is the division one. So this represents your g of x divided by your h of x. So if you want to pause it once again and try it on your own, the rules are there. Once you know them and have them, it's really just a matter of applying them and then doing some algebra. So So we have f prime of x, so we'll do the derivative of g of x. That's 2x minus 2 times h of x. But now we will subtract. So once again, the derivative of g of x times h of x, then you'll subtract, then you're going to do g of x, which is x squared minus 2x plus 1 times the derivative of h of x. Well, what's this derivative right here? X plus 3. Well, that's x to the first. We know the plus 3 is going to be 0, so what's the derivative of x to the first? Well, it's 1 times 1, x raised to the 1 minus 1, which is just 0. So what does it end up being? Just 1. And all of this is being divided by the denominator squared, which is x plus 3 squared. And now you just simplify. So on top it looks like you're going to get 2x squared. 6x minus 2x would be plus 4x minus 6. And then minus that entire quantity, minus x squared plus 2x minus 1 all over x squared plus 6x plus 9. So then it looks like the final answer to this will be, you got 2x squared minus x squared, so that's x squared. 4x and 2x is 6x. And negative 1 and negative 6 is negative 7. And you don't need to worry about canceling anything. If it cancels, that will just be your final answer there. And there you go. Alright, and the last one, just to kind of speed this up a little bit, be careful on this. This is a polynomial. You do have negative exponents. And you do it the same way you did the other ones. This would be negative 21x to the negative fourth because you are subtracting. Negative 1 times 2 is negative 2. And once again, when you subtract 1, that's negative 2. Then you have minus 8x to the first, and then you have your constant. Now that's really the derivative, right? I mean, right there. In terms of simplifying it, you just need to simplify the negative exponent. So anything raised to the negative exponent, you need to rewrite. So this would be negative 21 over x to the fourth minus 2 over x squared, and then since that one's not, it's just minus 8x. And that's your final answer. That seems to trip some students up with the negative exponents, but it's for each individual term, not for the entire thing. So be careful of this one. You'll see this one definitely again, and make sure you realize how to kind of work with those negative exponents. So that is it. Those are the rules for derivatives. I know there's kind of a lot there. That's why we're going to spend a couple days just practicing these rules, and then we'll get back into what this derivative actually represents, which we know, once again, slope of the tangent line. Thank you.